Good morning, students. Welcome back to the session. As you all know, I have already completed 6 chapters. Today, in this video, I'm going to start with the new chapter, that is chapter 7. Before going to start with chapter 7, just I'll start with the introduction, which is related to the present topic. In the previous class, means 9th class, all you learned about the definitions of what is an atom, what is element, and what is molecule, and what is a compound. Once will recall all these definitions. Okay, what is an atom? Atom is the smallest particle, and it cannot be further divided, and it cannot be visible through our naked eye, and it is the smallest particle of an element. This is the definition about atom. Can you give the examples of atom? We have so many atoms, different types of hydrogen atom, carbon atom, oxygen atom, nitrogen atom, like that we have different types of atoms. Now, element. What is the definition of element? According to the, for the element, Robert Boyle, who is that? Robert Boyle gave the definition for an element. According to Robert Boyle, element means any substance that cannot be further, decomposed into simpler substance by physical and chemical change. Once again, I'll repeat the same. What is an element? Element means any substance that cannot be further decomposed. Any substance that cannot be further decomposed into simpler substance by physical and chemical change. That substance is known as element. So what are the examples of element? For example, if you take water. First, if you take water. So this water, either by physical or chemical change, you can separate it. Means this water can be split into, can be separated into another compounds like hydrogen gas and oxygen gas. But element means like this cannot be further decomposed. For example, if you take pure gold, that gold by physical or chemical change, you can divide it into the small substance, means small parts, but you cannot decompose. You can make into the small parts, that element, but you cannot make into the another substance by physical and the chemical process. So if you take, this is the gold rod. So when you cut, you will get the 2 pieces. So in these 2 pieces, it contains the same type of atoms. Means only the gold atoms. It contains only the gold atoms only. It does not contain any other type of atoms. Only one type of atoms are available in an element. But if you take water, in that 2 different kinds of atoms of elements are there. So this is not an element. So are you clear about what is an element? Next, molecule. What is molecule? Molecule means 2 or more than 2 atoms. Either 2 or more than 2 atoms combine and form a molecule. For example, if you take hydrogen, it contains 2 hydrogen atoms. So it is a molecule. If you take Cl2, it is a molecule, chlorine molecule. If you take HCl, this is also a molecule because it contains two atoms, hydrogen and chlorine atoms. So molecule means it contains two or more than two atoms, then it forms a molecule. Then otherwise it is known as molecule. Next, coming to compound. What is a compound? When elements of two atoms combine and form a compound. For example, CO2 you take. So here two elements are combined and forming this compound. Carbon element and this is the oxygen element. And one more is sodium chloride. Sodium element and the chlorine element, these two means here the two different elements, either two or more than type of elements combines and form a compound. So this is about atom, element, molecule and compound. Now coming to this element. In this elements from the 17th to 19th century. Coming to this element, from the 17th to 19th century, scientists, they were discovered so many elements. Almost at present, they were discovered more than 115 elements. According to Wikipedia, it was given that 118 elements were discovered at present now. So from the 17th onwards, scientists were started their work to discover these elements. So like that they were discovered more than 115 elements. All these elements, when the number increases, so it was a big task for them, for the scientists to arrange all these elements in a systematic way. So they were arranged all these elements in a table according to their physical and the chemical properties of particular elements, and they were arranged in the form of groups and they prepared the table. That table is known as periodic table. What is that? Periodic table. Before to arrange this periodic table, earlier from the 17th to 19th, so many scientists, they were worked hard to arrange all these elements in a systematic way to keep in the periodic table. First, why they classified the elements in the form of periodic table or in the form of groups, and why they arrange in the periodic table, that all we will discuss in the present topic, in this present topic. So that our topic is classification of elements and the periodic table. So what is the chapter 7? Classification of elements and the periodic table. First, we'll find out the history behind the classification. From the 17th to 19th, at that time, day by day, the number of elements, the discovery of elements, not day by day, year by year, they were discovered these elements, and the number is gradually increasing. When the number is increasing, when the number was increasing, for the chemist to keep all the properties of each and every element, physical and the chemical properties of each and every element in their mind, for them it was the big task at that time. So so they thought to classify the elements. And one more example I'll give you. For example, if we go to the supermarket, without much difficulty we can buy the things whatever we want. Why we can buy? How it possible? Because all the things, they were arranged, they are arranging in a systematic way and in a group way, means in a simpler way. For example, if you go, all the fruits are one side, vegetables are one side, milk products are one side, grocery items are one side. Like they arranged all the things in the supermarket. So for us it is very easy to buy the things. And even suppose if you go and ask any medicine to by the medical shop, by the person from the medical shop, he gives without much difficulty. There were so many medicines are there. By seeing the prescription, easily he give the medicine. How was or otherwise how would be it possible? Because all the medicines, they were arranged in a systematic way. Because of that, easily he can give the medicine. Like that, how we are keeping the things in a particular way and in an organized way, like all these elements, if they keep in a system, in a particular way, in a group or systematic way, then easy for understand the properties of each and every element. So first they thought to classify the elements. Now you see Robert Boyle, 1661. Robert Boyle. By this his time, 13 elements were known. At that time, how many elements were known? 13 elements were known. At the end of 19th century, Lavoisier, another scientist, his name is Lavoisier, and his time more 11 elements were discovered. By his time, Robert Boyle time, 13 elements were discovered. Then after, at the end of the 19th century, Lavoisier time, more 11 elements were discovered. Like that, year by year, the number of elements were discovered. And by 1865, more 63 elements were discovered. Then 1940, totally they were discovered 91 elements from the natural sources and more 17 elements from synthetically. Means in the lab they discovered these elements. And 18th, at present, after 1940, at present, there were discovered more than 115 elements. Still they are searching for the new elements. Okay. So, up to 1940, they were discovered more than 100 elements. Almost 100 or more than 100 elements. So all these elements, they have to arrange in the systematic way. Earlier there was a classification. What is that classification? All the elements are classified into metals and non-metals. Metals and non-metals. Only that classification was there. But after aluminium, coming to the aluminium, this element has the properties of metallic and non-metallic properties. So that's what they thought, means scientists, because some metals, they're having the properties of metals and non-metals. So because of this reason, they were thought to classify the elements, and whatever they classified earlier, metals and non-metals, that classification was not useful and it is not sufficient to know the properties of different elements. So they were thought to classify the elements. At that time, 18th century, Joseph Louis Proust, who is that? Joseph Louis Proust, he was the scientist, and he said that hydrogen element was the building material for all the elements. Means what? For example, if you take a carbon, its atomic number is 6. Means carbon element is the combination of 6 hydrogen atoms. So like that, children used to play that building material, like they are adding and they used to prepare different shapes. So like here, hydrogen element is the building or material of all the compounds. For example, if you take carbon, if you take oxygen, 8. So it contains 8 hydrogen atoms combined and form oxygen element. So like that, his prediction, he said like that. Now, like that, 45 classifications were done. So when the number is increased, so scientists, they started to classify the elements, and different scientists, their own way, they classified, and they classified the elements. 45 classifications they were done. Out of 45, 46th classification was the periodic table. Means that table was accepted by all the scientists. So story behind this 45 classification, just we will discuss. Out of 45 classification, just 3 are given in our textbook, because these 3 are the famous classifications. So what are that 3 classifications? The first one is Doberieners classification, Newland's classification, and Moseley classification. So each one I will explain. The first one is Doberieners classification. How this Doberieners classified the elements. Doberieners, I will show the Doberieners. How he classified the elements. At that time, whatever the elements were known, that all elements, this Doberieners arranged as a group of 3 elements. He arranged a group, and in that group it contains 3 elements. It contains 3 elements. Means Doberieners, three elements he took, and he arranged as a group. So like that, he divided the elements into the groups, and he said that he arranged all these 3 elements. He arranged that all the 3 elements according to their atomic weights. According to their atomic weights. For example, I'll take one example. Lithium, sodium, and potassium. So at the time, how many elements were known? That all elements were arranged as a group of 3 elements. In that 3 elements, he arranged all these 3 in the ascending order of their atomic weights. So what is the atomic weight of lithium? 7. And what is the atomic weight of sodium? 23. And what is the atomic weight of potassium? 39. So like that, according to the increasing order of their atomic weights, he was arranged as a group. So 3 elements means that group is known as triods. That group is known as triods. So these triods are known as Doberieners triad. And he proposed a law. What is that law? The atomic weight of the middle element is equal to the average of atomic weight of the first and last elements. The atomic weight of the middle element is equals to the atomic weight of the first and the average of atomic weight of the first and the last elements. So when you add, this is left side, then how much you will get? When you do cancellation, you will get 23 only. So by this way he proposed the law. Once here I wrote, I'll read. When the elements with the similar properties, when the elements of the similar, so many elements were known, so many means may there 30 like that. So out of that elements, what are the similar properties of elements he made as a triad in the increasing order of their atomic weights, and the atomic weight of the middle element is the average of the atomic weights of the first and third element. This is his law. This law is known as Doberieners law of triads. So what is that law? Doberieners law of triads. And this law is very important for 1 mark, and sometimes they will ask you, give an example of Doberieners triads. So you have to write it as lithium, sodium, potassium. Okay, in our textbook there was a table. So here they are given as 5 examples. They are given 5 examples. So in each group you find out the atomic weights which are equal or not. Find out, then write your answers. Here one column is given, so write your answers in this column. Okay, now limitations. So Doberieners, he arranged at that time, at that time whatever the known elements he arranged like this, but in his arrangement some drawbacks are there, so that we'll discuss. So what are the limitations of his classification, Doberieners classification? The first one is, all the known elements at that time could not be arranged in the form of triads. Limitations: all the known elements at that time could not be arranged in the form of triads. Means he arranged the 3 elements as a group, but the 3 elements with the similar properties of elements. So at that time with all the elements he couldn't do the triads. Next, the law failed for very low mass or for very high mass elements. Here see, for fluorine, chlorine and bromine. Actually, what is his law? The atomic weight of the middle element is equals to the atomic average of atomic weights of the first and last elements. So this law is not this law failed for low masses and high masses. For example, we will take this fluorine, chlorine and bromine. So in our textbook it was given fluorine, chlorine, bromine. What is the atomic weight of fluorine? Fluorine is not given. Actually, fluorine maybe 20, chlorine 35.5, 9 and 18. Fluorine, yeah. Fluorine atomic number is 9. So 9 plus 9 means 18, its atomic weight 35, and bromine 80. Because in our textbook it was not given about fluorine. Okay, now so this middle atomic weight of this chlorine should be equals to average of by 2. Then it becomes 898 by 2. Then we will get 4, 9. So here we are getting 35.5 and this is 49. So these atomic weights are not equal. So this is one failure in his classification. in his classification. So next one. As the techniques improved for the measuring atomic masses accurately, the law was unable to remain strictly valid. Means earlier at that time there was no particular measurement to find the weight of atomic weight of an element. Approximately they were calculated the atomic weights, and at that time they were taken these values as a numerals, means no decimals, 1 2 3 like that they were taken. And at present the techniques are improved, and now they can find out the atomic weights accurately by using the up to the decimals. So due to that reason whatever he arranged these atomic weights, maybe there is a problem. As the techniques improved for the measuring atomic masses accurately, the law was unable to remain strictly valid. So these are the limitations of Doberian law of triods. But his invention, because he gave the relation that atomic weights should be correlated to the properties of elements, physical and the chemical properties of elements. So this made other scientists to do their work, means to do more type of classifications. This is about the Doberian law of triods and limitations. Thank you.